and welcome to the show. Today, we're going to review some calculations regarding the power handling of graphite. One of the first questions we're going to ask here is, what's the melting point of graphite? Ha! Got you! Graphite actually sublimes at 3600 degrees Celsius. This means that it'll go directly from a solid piece of pencil to a gas. The idea here is that when it becomes a gas, the connection between the terminals will be broken and it will no longer be handling the power through it. This may be a way to estimate the power handling of the graphite. Can we determine the power handling of graphite through temperature analysis? The actual question we're asking here is how many watts the graphite can handle before it breaks connection. Graphing the temperature at different wattages could allow us to estimate the amount of power the graphite will be able to handle before reaching its melting point and therefore breaking the connection. This may require some kind of linear regression and knowledge of the melting point. But how do we get the temperature readings? Measuring temperatures at 3600 degrees Celsius is no easy feat. You may be thinking to yourself, but Sean, what about an IR thermometer? You know, like a really good one? Don't you think I thought of that already? Who do you think I am? No, but seriously, I had this question myself. This would make answering the question pretty straightforward. Turns out, at basically any price range, the IR thermometers readily available to us only go to about 2600 degrees Celsius. That leaves about 1000 degrees Celsius off the table and require us to estimate a significant amount of data. There has to be another way. A bomb calorimeter. That kind of bomb calorimeter. A bomb calorimeter would remove the question of water vaporization when we drop a 3000 plus degree piece of graphite into water. We can use known specific heats as well as temperature changes of water to estimate the initial temperature of graphite. Let's look into that. Remember the age-old equation relating specific heat, mass, and temperature change? I do. If you look online, on the Google, you'll find specific heats of all kinds of things, such as graphite. The number I got for graphite was 706.9 joules per kilogram C. You'll probably notice my number here is 0.7069 joules per gram C. You may be thinking to yourself, but Sean, how'd you get that? Well, I divided it by 1,000. And then I got grams instead of kilograms. So the specific heat of graphite now matches the specific heat of water, 4.186 joules per grams degree C, and 0.7069 joules per grams degree C. What we can do, knowing that the amount of heat lost in the graphite will be equivalent to the amount of heat gained in the water when we drop the graphite in it, is set them equal to each other. Make one negative. Why don't we break that down? Step 1. Let's plug in everything that we know. We will use 100 grams of water in the calorimeter, just because that's easy. The specific heat of water, we already told you, is 4.186 joules per gram degree C. Then we got to multiply that by delta T. We're going to use 1 gram of graphite. This number is going to change based on the amount of graphite we weigh in a pencil. I don't have a scale at my house, okay? We're going to use the specific heat of graphite, 0.7069 joules per gram degree C, and we're going to throw the delta T back in there again. So let's plug in everything that we know. Room temperature for water, for instance, and all of those other values. And then we're going to simplify. Here, you can see I multiplied this by this to get that. Well, what do you know? Then I did the same thing here. simplify. Just keep on simplifying. We're just going to simplify all the way to the end of this little... Anyway, this is the equation we're going to get here with some math and science and algebra. Let's see if this checks out. Why don't we throw some numbers in there and see if it seems reasonable? Okay, well, this is the equation we just got. What if the graphite's 3,000 degrees to start? That's 3,000 degrees Celsius. We're using all Celsius here, okay? As long as they're all positive values, it shouldn't matter that we're in Celsius. I don't know if I need to say that. Anyway, plug in 3,000. We're going to multiply these two and move it over to the other side. We're going to multiply these two. We're going to add this to the other side here. Then we're going to divide it by this 419.3. TF will be 30.012 degrees C. So, if the water went from 25 degrees C to 30.012 degrees C, and the weight of the graphite was 1 gram, we know it was at 3,000 degrees C. Here's some references, and thanks for watching.